Hello and welcome to this class of Principles of Microeconomics. I am your teacher Muhammad Nadeem Sarwar. Today we shall discuss the production process of a profit maximizing firm. In this lecture we shall study how economists define production and how they model firms' decision in short run and long run regarding production. So let's start with the lecture. Students, in economics, we define production as a process by which inputs are combined, transformed, and turned into outputs. That is, a producer takes some inputs, changes their form or shape into a new product which has more utility. The inputs of the production process can be categorized into four different classes. First, land, which covers all the natural resources, all the gifts of the nature that help us in producing a commodity. Second, labor, which covers both physical as well as mental efforts of human beings that help in producing a commodity. Third is the capital, which are man-made resources, that is, the plants, machineries, and tools which help in production. A capital is in fact an output of some other firm, but for the particular firm under study, it helps us producing different goods. For example, if a firm is producing potato chips, then the potato chips making plant is capital for this firm. But this capital or this plant is also produced by some other firm. If we shall study that firm, then this plant will not be the capital of that firm. In fact, it will be the output of that firm. Therefore, we must be very careful in distinguish between output and capital. This is very simple. Everything that is man-made and that helps a firm to produce something is called as capital. Last is organization or entrepreneur. There is a need for a person or a group of person that makes all the decisions regarding how many laborers of which skill set to hire, what kind of capital to use, how which product to produce, in how much quantity should be sold in which kind of market, at what price, and so many other decisions. There is a risk involved with every decision. So, the organization or entrepreneur represents the decision makers and risk takers. Now, let's define firm and industry. A firm is an organization that comes into being when a single person or a group of people decide to produce a good or service to meet a perceived demand. For example, a person selling bananas on the cart in the street is a firm. A farmer producing wheat at his farm is a firm. Similarly, Pepsi, Coca-Cola, and other multinationals also represent the firm. Most of the firms aim to make a profit from their production. Next, industry. Industry is a group of firms that produce similar types of output. You have often listened the words like textile industry. That means all the firms that are in textile business. Film industry, that is all the production houses that produce films. So industry is a collective group of which firms are the members. An industry with many firms producing identical products is called as perfectly competitive industry, whereas an industry with only one firm is called monopoly. There is very difficult to find a perfect example of a perfectly competitive industry as well as of a monopoly. However, we can find so many industries that have few firms which produce homogeneous product, that is their product is similar but not identical. This kind of industry is given the name of imperfect competition or monopolistic competition. To produce a commodity, a firm has to make certain decisions. Some of these decisions are which production technology to use, how much of each input to demand, and how much output to supply. Before studying the decision-making process of the firm, it is useful to introduce ourselves with basic terms first. First of all, the profit. As we discussed earlier, the firms are into production for making profits, and most of the firms aim to maximize their profit. Profit is defined as the difference between total revenues and total cost. Total revenue is the amount received from the sale of the product. Let's assume that price of the product remains the same no matter how much quantity a firm sells. So the total revenue is the product of price into the quantity of the product sold. Whereas total cost in economics is defined as the total payment which is necessary to be made for the continuity of the production process. That is, in economics, we do not define costs as the payments or the expenditures that are necessary to produce a commodity. We aim for the continuity of the production. That is, the vision of an economist is long term. An economist will want to ensure the continuity of production in future. And to make it happen, all the expenditures that he or she has to make will be summed up as total cost. We shall explain the total cost in more details in coming lectures. However, for this, be aware of that the total cost includes out-of-pocket costs, that is, those costs that must be paid to the outsiders, called as explicit costs, normal rate of return on capital, that is, if the owners own capital, then they must consider how much they could have earned if they would have lent their capital to some other industry. And lastly, the opportunity cost of each factor of production. In simple words, as we know that for the production we need the services of four kinds of factors of production, land, labor, capital, and organization. So the sum of payments that are necessary to keep these factors in production line is called as cost. And these payments are given the name of rent, wages, interest, and profit. Next is the technological constraints on the production. We cannot produce anything with our own desired inputs. For example, if you want to produce a car, you hired 10 people, give them hammers, and gave them a welding plant and ask them to produce a car. It will be impossible for them to produce it, since for producing car they need so many other things like plastic, iron, aluminium, glass, etc. etc. Therefore, only certain combination of inputs are feasible ways to produce a given amount of output. These constraints are put on production process by the nature, and these are called as technological constraints. Then we have the production set, which combines all the inputs and outputs that comprise a technological feasible way to produce a commodity. That is, let's say you can produce 4 kilogram of potato chips using one plant, 2 kilogram of potatoes, 5 kilogram of other things, and 4 labors. Then it is definitely possible to produce less than 4 kg of potato chips as well using same combination of inputs. Therefore, the production set includes these inputs and the output level up to 4 kg of potato chips. Similarly, it also includes all the other combinations of inputs that can produce up to 4 kg of potato chips. However, the production function shows the maximum quantity of output produced using alternative combination of inputs. That is, the production function is in fact the boundary of production set. We can more understand both these concepts using following graph. Here, the line which is given the name of production function represents the maximum quantity of the output that can be produced from given input. However, it is also possible to produce lesser quantity of output with same set of input. Therefore, all these quantities that are possible to be produced are the part of production set, whereas production function represents only the maximum quantity of output. Mathematically, we represent production function as, and usually for simplicity, it is written as this. That is, taking only two factors in consideration at a time and assuming that others behave in similar way. Next is the marginal product of an input. The marginal product of an input is the additional output or change in output because of using one more unit of that input. holding all other inputs as constant. That is, the marginal product of labor is the rate of change in quantity of output to a change in labor. And marginal product of capital is the rate of change in output to a change in capital. We can also say that the marginal product of an input represents the slope of the production function. Next is the average product of input, which is the output per unit of that input. The value of average product of input can be obtained by dividing the total quantity of output by the number of units of that input. Next, we discuss short run and long run. In economics, we define short run as the period for which two conditions hold. Number one, the firm is operating under a fixed scale. That is, at least one factor of the production is fixed. Second, the number of firms in an industry remain constant. That is, firms can neither exit nor enter into an industry. Next is the long run. Long run represents the period of time in which there is no fixed factor of production. That is, the firms can increase or decrease the scale of production, and new firms can also enter and exit from the industry. We represent long run as students. We can understand the concept of short run and long run better with the help of an example. Let's consider a firm that has 4 plants and operating with 5 laborers, producing a certain quantity of a commodity. Firm decided to increase its production. It hired more laborers, but the number of plants remained the same. That increased the level of output. After a certain period, firm again decided to increase the quantity of production. Again, it hired a few more workers, but the number of plants remained same. Now, after some time, firm realized that the market demand for its product is increasing. Therefore, to increase the production, now the firm decided to increase both the units of capital as well as the number of laborers. After some time period, when the demand grew more, firm decided to remain with same number of capital but increased the number of laborers. Now, if we study the first period, this is a short run time period. If we study this second period, this is again a short run period. However, if our study time covers all this period, then we can observe that during this period, both the units of labor as well as units of capital are changing. Therefore, it is long run. Keep in mind that in economics, we do not define short run and long run with the length of time. That is, we do not say that, for example, a time period of 1 year or shorter is short run and a time period of more than 1 year is long run. This is wrong. In economics, this is not defined like that. In economics, we just keep an eye on the factors of production and look if they are during the time period. Is there any factor fixed or there is no factor fixed? When there is no fixed factor, it is long, and if there is some factors, some important factors which are held constant, then the period under study is shortened. Now let's discuss short-run production function or short-run production technology, also called as short-run technology. Short-run production function or short-run technology maps inputs with maximum amount of output that can be produced holding at least one input as constant. Here the capital is kept constant. The increase and decrease in the production is because of increase or decrease in the number of labors. The behavior of such production function is studied as the law of variable proportion, which states that for a given production technology, a continuous increase in one input keeping the other fixed results in increasing the output at an increasing rate initially, then increasing the output at decreasing rate, and finally the output starts to decrease with an increase in the input. Let's study it with the help of a table and diagram. Here we assume a firm which has certain fixed unit of capital. However, it is employing more and more labors. At 0 unit of labor, its output is 0. It employed 1 unit of labor, output reached to 10. Employing 2 units of labor, output reached 26. When third labor unit also added, the total output reached at 65 and so on. We can calculate the marginal product of labor by dividing the change in total output with the change in the labor units, and calculate every product of labor by dividing the total output by the total number of labors. Here we can see that initially, by employing more and more labors, the output is increasing and the increase at each time is larger. This happens till third unit of labor. The reason for this is that the plant is very large and the initial number of labors, 1, 2 or even 3, are not able to fully utilize the plant. Therefore, with an increase in labor, the utilization of plant increases and that increases the production by a greater amount. In this region, we can see that both marginal product and average product are also increasing and these are positive. But most of the time, marginal product is greater than average product. From the next units, we can see that up till 8th unit of labor, the output quantity is also increasing. But now the increase at each additional labor is lesser than it was before. This happens because now we are approaching towards the maximum utilization capacity of the plant. As we shall approach near and near to that, the net increase in output will be smaller and smaller. We can also see that this is reflected by falling marginal product of labor. The average product of labor is also falling, but now the rate of fall in marginal product of labor is higher than rate of fall in average product of labor. At 8th unit of labor, we can observe that marginal product of labor is 0 and total product is at its maximum quantity. Now, if the firm employs still more laborers, because the capital is already being utilized at its full capacity, so employing more laborers will be of no use. It will, in fact, increase the problems for existing laborers and therefore it will result in decreasing the output. This is represented by the help of graph as we can see that the total product is first increasing at a higher pace, then the pace of increase is getting slower, and finally, after touching the maximum point, the curve starts to fall. Whereas the marginal product is first above the average product curve and then it is below the average product curve. The behavior of average product curve is also interesting. It is increasing at its maximum point. It intersects marginal product curve and then declines. This is summarized as next is the law of diminishing returns. Students, as we have already seen that additional units of variable inputs do not guarantee the increase in output at increasing rate after a certain point. That is, when additional units of variable inputs are added to fixed input after a certain point, the marginal product of variable input declines. This is given the name of law of diminishing returns. Always applies in short run. It happens because not only that the capital quantity available is scarce, like the quantities of all the inputs available, but its productive capacity is also limited. So, after optimal capacity utilization, there is impossible to increase the production using the same amount of capital. Now we turn to long-run production function. The long-run production function or long-run technology represents the relationship between inputs and maximum quantity of output that can be produced. Here, none of the inputs are held constant. This is represented as we use a map of iso-quant curves to represent long-run production function. An iso-quant curve shows various combinations of two inputs that can produce same quantity of output. Word iso means same and quant is for quantity. So on an iso-quant curve, the output quantity remains fixed. This is represented as a slope of iso-quant curve is given the name of marginal rate of technical substitution that shows how many units of capital a firm will have to sacrifice to employ one additional unit of labor, keeping the output same. Like in difference curve we studied in production, an iso-quant curve is also decreasing in slope, and higher iso-quant curve represents higher level of output. The optimal output decision is one that either produces maximum output with given budget or produces given output at lowest cost. Therefore, for optimal output decision, it is necessary to keep the cost in view. Now we introduce the cost side. Here, with two inputs, the cost represents the total amount necessary to pay to the owners of both inputs to keep them engaged in production process. That is, the cost represents the total wages paid to the workers and total interest paid to the capital. Here, wage rate is W and capital's interest rate is represented by R. Solving it for capital, that is for y-axis variable, we have graphically we can represent it with the help of iso-cost curve. Now let's study the optimal production decisions of the firm in long run. First, we study the case of choosing cost for a given output level, that is output constraint cost decision. In this case, we assume that the manager of the firm is asked to produce a commodity in a given quantity. Now he can choose various combinations of labor and capital that ensure the production of the commodity in specified quantity but at minimum cost. The given output is represented by iso-quant curve named IQ1. The manager wants to produce it at lowest cost represented by GH, but with this cost the available combination of labor and capital are unable to produce the commodity in given quantity. With increased cost, he can produce it at point E1 represented by iso-cost curve AB and point E2 and E3 on iso-cost curve CD. As we know that in this case the profit of the firm will be maximum when the manager produces the commodity in lowest cost. Therefore, the optimal decision will be at a point where lowest possible iso cost curve is tangent to given iso quant curve, that is at point E1. Next is choosing output for a given cost. That is, we assume that now the manager of the firm is allocated a certain budget. He can hire any combination of labor and capital with this budget and can produce the commodity in any quantity. Now, in this case, the optimal decision will be producing the most quantity possible. That is producing the maximum quality that is possible utilizing all this budget. Graphically, the given budget is represented by the given ISO cost curve represented as if AB. The manager wishes to produce more quantities of goods represented at higher iso-quant curve IQ2, his budget is limited for this production. Therefore, the manager can produce some combinations on IQ0 or a combination on IQ1 where the ISO cost line is tangent to ISO quant curve. As we know that higher ISO quant represent higher quantities of goods, therefore the optimal decision will be producing at IQ1. This is possible at a point E where the given ISO cost line is tangent to highest possible ISO quant curve. Now let's discuss the concept of returns to scale. Returns to scale shows the response of output to a change in inputs. If the inputs increase in proportion, what will be the increase in output? This is the question that is answered by returns to scale. Now let's suppose that the output increases in the same proportion to an increase in input. That is, if we increase the inputs by 10%, increase labor by 10%, increase capital by 10%, the resulting output is also increased by 10%. If this is the case, then this is called as constant return to scale, represented as. The second possibility is that the increase in output is more in proportion to increase in inputs. That is, let's suppose the manager of the firm doubled the quantity of labor and capital, but the output produced as a result of doubling both inputs is higher than double of the initial level of output. Then this situation is called increasing returns to scale. This is represented as. The third case is when increase in output is less in proportion to increase in inputs. If this is so, then this is called as decreasing returns to scale. Students, the concept of constant return to scale is hardly seen in real life. However, it is very important theoretically. Increasing return to scale is possible if, with higher production, the experience of the labor and is increased, specialization grows, and there is a better utilization of capital. Whereas decreasing return to scale normally happens because with more number of people, the human resource management issues also arise. Therefore, doubling both the inputs may not result in doubling the output. Lastly, we discuss the expansion path and factor intensity. Given the factor prices and technology, the optimal expansion path is determined by the points of tangency of successive ISO cost lines and successive ISO quant curves. In simple words, The expansion path shows us the growth path in the production because of an increase in the budget of the firm. This is quite similar to income effect we studied in consumer theory. Next is factor intensity. A technology that relies heavily on human labor instead of capital is called capital intensive technology. That is, when the firm wants to increase the output, it increases both capital and labor, but increase in labor is more than increase in capital. This could be because the lower wage rate in the country or because the nature of the product that a firm is producing. Similarly, a capital intensive technology is one that relies more on capital than on labor. The expansion paths in both kinds of technologies are shown like this. That's all for this lecture. Please post your questions and give your feedback in comments. Also consider liking the video and subscribing the channel. Thank you and goodbye.